So welcome to the SmartQA Musings this week, which as you know is the gentle flurry of interesting thoughts. Unlike probably a lot of other musings, I will stray away from the typical testing today also. And today the musings are centered around three other disciplines and what it means to us in QA and how they possibly have a significant bearing in what we do. And I'm quite sure you will appreciate as we go forward as to what their connections are. And the three disciplines of interest are economics, sociology, and anthropology. And what does it mean to us in the discipline of QA? Many years ago, I think when I was a student in college, somewhere about 85 or so, in the IEEE spectrum I saw job opportunities for anthropologists, and this was an ad from Intel. And as a young technology student of electronics and communication, I could never understand as to why a chip company, Intel, was looking for anthropologists. I'm not sure if I got the date right of 85 or is it 95, but I think I was pretty young, so I certainly didn't get it. I think it was more like 85, 86. And I could never understand what is the connection between anthropologists and jobs at Intel research. Well, it took me many years to kind of understand the connection, and by the time the hair had grown grey. But I got very interested with it, especially when I moved into quality assurance. So that's the story that I want to weave and then see what the connections are and what is interesting about it. Okay, so let me kind of open it with a bunch of stories which all of us are aware of, and then slowly weave the connection to each one of them. I'm sure you remember this many years ago, not too long, a couple of years. One fine day, millions of systems crashed. 8.5 million is what internet says. And they all crashed, airlines were grounded, hospitals were shut down, they became on manual backup, banks became offline. The whole world came down, apparently, for some time. The estimated cost, as per the internet goes, was said to be 3 billion, though I heard number like multiple times that number in a recent conference. It brought down critical infrastructure across continents. Time to fix. For some people, they got back the systems in a few hours. For some, it took many days. Now the question is, was this a technical failure? I'm sure all of us must have researched on this topic or got to know that it was basically a bad push. A push which resulted in certain things being pushed down all the way down, and that resulted in a major shutdown as far as Windows upgrade was concerned. A Windows update went faulty. And the question therefore is it a technical failure or something deeper? Now, let's dig in and find out for ourselves as we go forward from the three lenses that we're going to look at, which we probably have not typically applied to testing. The lens of economics, the lens of sociology, and the lens of anthropology. So as we all know, economics is about business and money, in some sense. Money, supply, demand, so on and so forth. Sociology is about society, behavior, trust, culture, and so on. And anthropology is individual human behavior. And we will look at it from those lenses. Now, interestingly, there's another, if you predate it back, there's a lot more disasters. One of the disasters that we had was Night Capital. Night Capital in 2012, they lost a few $billion, a few hundreds of millions of dollars overnight. Because they were into algorithmic trading, some push happened of a piece of code, the system started buying, and it bought stuff which it was not told. And remember, when you buy, you have to also settle in reasonable time, I think a day or into the day or something. I think it bought something like about $500 million worth of trade, and that was the end of the company. So in 45 minutes the company went down the tube. $440 million of loss. This is 2012. Take the right side, the manufacturing. 1970s. They were looking at cars, they were looking at manufacturing, and they were really asking, how do we catch defects? And they moved on to how do we prevent defects. So what's the story? Two questions, 40 years apart. One led to more inspectors control the left side. The right side led to Toyota, which we know now is Toyota quality management and prevention and so on, and it led the entire automobile industry into a massive revolution, especially from the Japanese side. But two questions, and we're still learning from manufacturing yet. So, on the left side let's look at it from the notion of money now. The way Japanese probably operate is they value quality more than the cost of the time. Silicon Valley values time more than anything else. So, Facebook said, move fast and break things. And they were primarily interested in pushing stuff every day. And we know that. Toyota, on the other hand, for example, Japanese car companies, the Toyota said, stop the production line if one defect is found. Jidoka, as they said. Contrasted with the one on the right. Move fast and break. Same activity of building products. But totally different economic models of failure. Why? What does it mean? Toyota they gave the power to the workers. They helped them understand if there is a fault which could be crazy enough. So they said, if the fault is fixed right at the beginning, before it hurts the entire production line, it's $100 maybe. If it is shipped all the way, maybe it is thousands of dollars maybe. And therefore they understood the cost of prevention and early detection vis-a-vis. So they looked at it from cost perspective. Facebook was slightly different. They said ship fast because we need market advantage. It's okay to fix later. We can accept technical debt. Now, is one any better than the other? Both approaches seem to work. But just remember, it is contextual. What happens when a Japanese bank tries to do the latter with your money? It may not work, right? Because I certainly think that you would not be happy to lose your money. So the first thing that we want to understand is quality has economics, right? And therefore we bring about the term called the externalized costs in action. Let's go back to CrowdStrike. CrowdStrike, because of the push, because of security, because they were a security company, which cost the world quite a bit, as we talked about. Airlines, hospitals, every industry suffered. But you know what happened to CrowdStrike? After a few weeks, their stock price recovered. They were trading high. They were about $500 then. So their business came back to the good business, right? They get back there. Unlike the Knight Capital, which lost its company. So they recovered. But airlines lost millions. Banks couldn't run transactions. So it basically cost a lot of loss to other companies. And therefore, it is like a classic economic pattern. The party taking the risk doesn't bear the full cost of failure. So keep in mind, every time we say ship now, fix later, we're making the same calculation. So there is externalized costs in action, which is an economic aspect, which actually comes into play in probably what we sometimes do, which is from assurance, maybe software assurance. And today, we all know it's Now, the funny thing is, the book called Quality is Free by Phil Crosby was written. Phil Crosby was written many, many years ago, where he talked about costs of prevention, early detection, finding, fixing, and so on. So there was something called total cost of quality, and so on and so forth. And therefore, there was something called a COQ. All of them grounded in the economic aspect. Let's come back home. I'm sure we must have used this portent some time ago, right? Vaccination. A brilliant system, a great piece of code that was done at that point in time. What was the problem? Massive demand. Sometimes inadequate. 10 million people tried to register on day one, it crashed. And I'm sure you must have seen that with a lot of our government systems that we have in India. Another one, GST. I don't know if you remember what the Secretary then of Finance said about GST when it was going to be launched. In fact, he mentioned before it was launched, these systems will have problems, so we will deal with it. It will stabilize in a few months. That is our approach. Now, if you go back, you know that GST has a deadline. You miss the deadline, you pay fine. And businesses paid fine because their server crashed. They could meet the deadline. So what are we talking about? The same idea last time what we talked about. We paid for it, right? Somebody else pays for the economic from their pocket. And in this case, a lot of these systems, especially our government systems, are designed for average load, not peak demand. So I'm sure we've seen that in exam portals, online examinations sometimes, obviously in land registration sometimes, and so on. Now, remember whose money is it? Citizens' money. So if I don't file a GST on time, who pays for it? The citizen, the company. So what does it mean? Our taxes are in use to build the system. And we also pay the penalty when it fails. And you see the economics in action here, right? So we look at it as a system and we test for issues, but then the impact is much more. In this case, it's the impact is on the context of economics. So if we could only probably be a little more sensitive and look at it from the lens of economics, maybe the actions that we do, the strategies that we adopt, may be different. It's not just about technical testing anymore. Let's move on to the next lens, sociology. 1986, January 28, Challenger lifts off, and then after a few minutes, or a few seconds, if I get the exact duration of time, not too long, it explodes. The 7 astronauts die. The Challenger, the finest equipment, apparently. Something that is amazing, that we could actually have a reusable rocket, explodes, killing people, setting back the program for many years. Economically, of course, NASA lost a few $1 billion. Now why? So Richard Feynman, the physicist, was called along to the investigation committee, and he did find the answer to the problem, the reason. And he conducted that famous experiment called the O-seal experiment. And he actually used that to show what was wrong. And what was wrong? If you remember, there was a seal which prevents the hot gases by going back. So obviously there's a big engine, it's burning fuel, it's emitting gases, and it's moving forward. And there was a seal which prevents these gases coming back into the Challenger. That gave up. And the O-seal failed. It is probably a few $100 worth of equipment which destroyed $1 billion equipment, brought down a nation, killed people. And why did this thing? Because at cold temperatures it became brittle and it couldn't hold its properties, and that was the deal. Not a complicated problem. Now, when they did the analysis and subsequently they found that this problem was known. It was supplied by an external another company. The engineer had talked about it and said, look, it is not working well at super cold temperatures. Be careful. And he had put out a note. But the NASA management or the company management maybe overruled them. There was political pressure, schedule pressure, budget pressure. There was pressure. 7 people died. It was not technical ignorance. It was social hierarchy. The hierarchy silenced the truth. And that's what we understand from the societal aspect, sociology. So think about it. How many times some of us have identified a risk, found a bug, but have been silenced because somebody with more authority pushed it and we succumbed to it. So is it just a bug? No, it's not a bug, right? It's a technical bug, but then it has to go up all the way and actions have to be taken. So, Challenger, what was the problem? It was not a problem of technical quality assurance. It was a problem of sociology, where we had hierarchy. A simple message, authentication failed when I do another. Biometric identities, one of the largest in the world. A pretty amazing system that we have built. Sometimes this was the problem. The problem was manual laborers who do work with their hands, their fingerprints don't scan properly. Because there were no fingerprints, because they did a lot of physical labor. And therefore, what does the system say? Authentication failed. Is it a bug? No, it seems correct because I couldn't recognize, I failed. What's the result? No authentication simply means to them, to the workers, no subsidized food, no access to the bank, no government services. Their remembering of money doesn't come in. So what happens here? We just talk about it like, oh, this is a bug because the sensor couldn't detect my fingerprint and What really happened was the system that was designed to prevent a fraud became a source of exclusion. A digital exclusion of certain people in the society. It was supposed to build trust that I am so and so. Authenticate. And that's a paradox. So, you see here, it may not be a pure software-ish only kind of a problem. It's a system problem. But what is the impact? A social impact. The impact that guy doesn't have food, or doesn't have money, or doesn't have access to any of those. And that's what happens from an issue of an issue to the larger context of the society at large. Interesting to our own home talk, we all talk about user acceptance testing. And I'm sure you must have experienced it in some times. I've seen that quite a few times. User acceptance test not necessarily is done fully by actual users. What do we mean by that? UAT typically meant you put the software in front of real people, in the real environment, with the real data, and then they do. Slowly over time, we put the name called user testing, and then maybe the product manager or somebody within the organization came up with user acceptance test cases. Maybe the product manager ran it, and then we had compliance. We said, we did user acceptance testing. So we replaced the real user judgment, the human judgment, with procedural compliance. Because real users don't follow happy paths. Whereas, maybe people within the company, the builders, who are not necessarily developers, could be the people who are managing the product, do it in perfect conditions. So, are we getting really user voice and sometimes? And therefore we don't. So it's a shift of power. Okay, somebody within the organization runs it or comes up with scenarios and gives it to them, and you in a way, you shift. So you shift from the user voice to an internal authority, and maybe therefore sometimes disaster occurs. That's a power shift, again, a sociological aspect. So we talked about from the lens of using some examples as to what it means from the lens of economics and the lens of sociology. Now let's move on to the notion of human behavior, anthropology. A common thing that we encounter every day. We say the bug. We make it look it's an external piece. We don't say it's my mistake, our mistake. And the bug stuck because Grace Hopper in 1947 found the bug in a ball. And then the word stuck and it got stuck into software. It seems like an external stuff got into my code. It's not my problem. External invaders. We don't say it's my mistake. Whereas if you say mistake, it means a human did wrong. A bug. Somebody got inside. So you know what that means? It simply means it changes my behavior. Because I'm making it look like it's an externalism, not something that I own. So which means if you say I'm hunting for bugs, rather than I'm trying to prevent or ascertain potential mistakes and correct them, changes the way I think. So the narrative from a cultural view lens, it changes or shapes the responsibility that we have towards experiences and value to our customers and users. And that's an anthropological aspect. It's nothing to do with technical aspect. Look at this way. Look at it another one from a cultural and anthropology part. Here is the left side, there is a picture of where we go to the market, we buy some stuff. This was what we probably were doing many years ago. And we liked touching the product, smelling the product, seeing the product, feeling the product, and having a conversation with the shopkeeper, and then of course we liked it, we paid cash. Now what do? We read the reviews. We trust the algorithm recommendations. We do a one-click purchase. Right? It's interesting that over time, we seem to sometimes trust the algorithm more than the human. You know what's happened? We've actually changed our cultural practice, our own trust and decision making. So if you see a 4.9 out of 5 rating, we'll immediately say click the button and buy it or reserve the hotel or whatever. In the previous world, you would have probably called somebody. So it's interesting that anthropologically we have learned to trust the strangers and the algorithms in a way. From our own QA aspect, we seem to trust automated testing the way the consumers trust online reviews. Don't get me wrong, I'm not talking about online testing being bad. I'm just saying our trust factors have shifted. It's no more just human. So, and I'll kind of round it up in a few minutes with the AI part, and kind of you will see the connection too. A second story in anthropology. There was a crisis in the 80s when, with respect to cars. American cars were fat, they were guzzly, big, but not necessarily of great quality. And then Japanese took over, and then they made some of the finest cars. And then Americans had to reinvent the way they made cars. Now, how did that happen? One gentleman is very instrumental in doing this, in making the Japanese what they are today, and I'm sure we know him. Professor Edwards Deming. He was a statistician who was more recognized in Japan, so he moved down to Japan and then he taught the Japanese. And what did he teach? He said most of the quality problems are system problems, not individual problems. So he did not say, hey, you made the mistake. He said, system has a problem. Find the variation, find the problem, find the cause. And then he built this Deming philosophy. And he said, you can't find it. You have to design it in. And manufacturing started understanding that variations occur. Systems have a problem. They set up practices and processes and whatever tools that they could do, and manufacturing changed. So suddenly, the quality of the automobiles became amazing, the Japanese ones. You can't inspect a quality in, you have to design it. And that's what we're learning in software. 40 years later, we're still not there yet. that we need to work at it early on, not just find it. The question, are we learning from their journey? Are also going through the repetition of the same mistakes. But remember, it was 1980s. So if you go back to TQM and you go back to the Agile, etc., Agile is much more later, and it's inspired by some of those ideas that have been in manufacturing and tried to be adapted. And we also see the fact that the notion of Agile is built in some sense on the notion of certain aspects of social pieces, but they don't have a very strong connection to economics and anthropology. So we have ceremonies and rituals and obviously trying to work with people rather than documents and stuff. Those are nice. But it still looks at it from speed, it still looks at it from velocity, it doesn't look at it from value as much as it should possibly. So there are still challenges. So that's a take from the anthropology. Now, the newer notion of humans and AI. Now, the machines are probably an extension of ours today. So we seem to collaborate with it much more deeply. And the future, therefore, is interesting. What used to be deterministic systems is no more deterministic. How do you test something that's unpredictable? How do you test something that does something interesting? It does seem to provide answers confidently, despite the fact it is wrong. And then, of course, we are going through that cusp at this point in time, and I think we've talked about it in a couple of previous ones. The future really isn't about us versus them, human versus the AI. It is really a far more sharper understanding of how economic, social, cultural forces shape this collaboration. What newer rituals are we creating? What kind of relationships of trust are we building with algorithmic systems? So we're not talking about AI as such. What we're really talking about is, look, we need to probably go much more deeper to be able to symbiotically work much better. And that's where the cusp is today. So coming to the last couple of slides, so to speak, it's probably what is needed is in some sense a synthesis. On one side we want to catch bugs, on the other side we want to design good systems. And still what we need is probably the three lenses, because any decision of testing in whatever stage of the life cycle is based on three things simultaneously. An economic choice. Do we really appreciate who pays the cost of a failure and what the failure is? And what it means to the end users. It's not just about the software going down. It could be no food. It could be somebody going bankrupt. It could be somebody dying, etc. A social negotiation, the act of how power can redefine and define quality, which we know when we go into a transformative mode of the organizations. And finally, a cultural statement. What do we really value? And so a synthesis of these three lenses, in addition to all the wonderful things that we are doing in this industry, is probably very paramount today. Because quality is anthropology. Understanding human systems, markets, trust networks, cultural practices is as important as understanding technical systems. And therefore, appreciate that the Q quality is a human problem that happens to involve technology. It is not a technical problem with human interference. And therefore, the best QA professionals aren't just about good at finding issues or bugs. They are good at reading the context that creates or prevents bugs in the first place. So the parting statement that I have before we close down is this. Maybe what we need to become is anthropologists of your organizations, economists of your processes, and sociologists of your teams. Thank you so much.